Hi everybody. I'd like to talk to you about the data that is coming out on getdata.ai and is the research that we're putting forward on the COVID-19 pandemic. And I'd like to do that by first examining the latest data and then explaining our methodologies and why it's so different from what is being reported. So first off, we've just crunched the data, and the United States has set a record for deaths per day, and it's increased 84% to 4,591 deaths. The slowdown is fake news. And so we already know that things are increasing, and you'll hear this metric of, there's infected, there's deaths, there's death rate, and then there's infected by day, so infections per day, deaths per day, and death rate per day. And so I'm going to talk to you about the various ways to view this and how they can be skewed and misinterpreted, and try to give you the best picture so that you can understand the situation. Okay, so first, let's just look at how the United States is doing versus other countries. And what you see here is a chart in 3 dimensions of countries. And on the x-axis, you have infected, right? So the more infections, the more you go to the right. On the y-axis, you have deaths. So the more deaths, the more you go away from us. Okay. And on the z-axis, you have death rate, and so the higher the death rate, the higher the series is. And so all 3 of these are bad, and ideally you want to be over here, right? You want to be low infections, low deaths, low death rate. Okay, let's look at a couple of countries. So first, the United States. The data is represented in 3 numbers, which correspond to the axes, right? So the first number is infections. At the time of this writing, the infections are 666,801, staggering. The second number is deaths, so there's 32,916 deaths. Third number is percentage, and it's 4.93%, and that's the death rate. So the death rate is 4.93%. And so what that means is, if you look at this series, right, the US leads in infections, right? No one is even close to us, and that's why we're so far to the right. The US leads in deaths, right? We have 32,000. No one is even close to us. That's why we're so far into the screen. Okay, and we're not the leaders, though, in death rate. Right, we are at 4.93%, and there are other countries like the UK, which is the current leader in death rate for countries with high amounts of infections. There are other countries that are at 15% death rates, but they don't have near the amount of infections, so it could be spurious data. They may not have enough. It could be just an initial spike, which is what you see over here, and I'll explain this spike. So now let's look at the UK, right? So the UK has 104,145 infections, 13,759 deaths, right? And 13.21% death rate. Death rate is defined as the amount of people who have died divided by the amount of people who are infected. And specifically, the people who died have been tested for COVID, right? So let's say there's 10 people, okay, and let's say that we tested all of them, okay, 5 of them, or let's make the example more practical. Let's say there's 100 people we've tested, and 13 of them have died, right? So then you would get a 13 death rate. Here we have 13.21. Now, if there were 200 people and 100 of them were tested, and let's say 150 people died, okay? Now, of those 150 people, let's say 100 of them were tested, right? Then it's hard to say what happened with the other 50. Now, the U.S. Has recently, in New York, counted people who have died as a consequence of not being able to be cared for, right? So there's a transitive dependency in that you may not have died because of COVID, but specifically because you were infected with COVID, but you died because COVID prevented you from getting care, right? You weren't able to get the care. And, you know, I think it's an important number. I would not discard that, right? But perhaps we report it as transitive deaths, right? Or yeah, you know, it's, yeah, indirect deaths. And so either way, and if you look at France, which or sorry, Italy, which used to be the death rate leader at 13.12%, you know, those numbers are staggering. Those are incredibly high numbers. So now, what you may notice is that the death rate seems to be increasing over time. And it may be that we start to approach these levels that the UK, Italy, France, and Spain are at. They're all above 10%. And you know, questions are coming out now as to, well, people have been dying in the US and we don't have mass testing, so perhaps a lot of people died who had COVID and we didn't know that. And had we known that and accounted for it, perhaps we would be at a higher death rate like these countries in Europe. And it is, you know, unlikely to me that the UK, Italy, France, and Spain all have totally dismal healthcare systems and, you know, can't handle the situation altogether. And it's also interesting that they cluster together, right? So I find it unlikely that they're inept at healthcare. I think the disease, sorry, the virus is just that deadly. Right? It is a serious problem. The flu, you know, to give you an comparison, its death rate is 0.1%, right? So that means out of 100 people, 0.1, more, you know, a more tangible way to say that is out of 1,000 people, one person dies, right? Out of 1,000 people in the UK, 130 of them die. Right? Out of 100 people, 13 people die. You probably know 100 people. Can you imagine 13 of them just, you know, passing away from this thing? So, and the idea is that we have to control the infection so that it doesn't kill every 13th person, right? Or yeah, or every 13 people out of 100, right? You want to prevent it from spreading so that it doesn't kill at what its lethality is right now. Because losing 13% of the population is unbelievable, right? Okay, so that's the first chart, and you can see that, you know, we lead in infections, deaths, and we're rising in death rate. And over here you can see Europe is in this cluster up here with high death rates, not as many infections, not as many deaths. New York by itself has more infections than any country besides the United States. It's one of us. It doesn't lead in deaths yet, but it's at 14,832 deaths. And New York has a death rate of 6.63%. So, you know, that also is interesting. You can see that its death rate has jumped, right? And this is, you know, partially due to the accounting change and how New York has classified it. And you cannot not count them, right? Perhaps you count them a different way, but I mean, at the end of the day, we're going to ask how many people did COVID kill, right? And if you have to give a number, I would give the direct and the indirect number because that's what happened, right? This thing arrived upon us, and these are the amount of people that died. So I don't disagree with what New York has done here. It can be classified a different way, but push comes to shove, this is the best we can do right now, right? And there's all kinds of optimizations we can make, but everybody's trying to move as fast as they can and report as best as they can so that we can make good decisions. What I want you to get from this is it's bad everywhere, right? There are questions about Germany's numbers. We'll talk about China in a minute, but you know, these are superpowers in Europe, and they're all getting crushed. We're getting crushed. And so the virus is real, it's on the move, there's no slowdowns. You know, if you even look over here, and we'll talk about what a real slowdown is, there's a slight curve over here. I'm not saying that is the slowdown, that you can only use the first and second derivatives to show what a slowdown is. But even if you look at that, that is a drop in the z-axis, and that just is saying that the death rate fell slightly. But they're still moving this way, which means more deaths, and their rate of infection is nothing compared to the United States, but it is on the move. Okay, so globally, it's a problem, and the death rate in the United States may rise, and it may be much more than what we expect, and where we are now at this 4.93%. Because again, we've not tested everybody. We don't know. There's certainly people who have died who have not been tested. We don't have mass testing in place. We've got to get that so that we can figure out exactly how lethal this thing is before we open the country back up. I mean, imagine that the country is actually, you know, the death rate is 13%. I just can't believe that the UK and Italy are that, you know, incapable of managing their populations. So there are smart people everywhere in the world. These are not third world countries. They have apparatus, they have infrastructure, they have economies. It's unlikely that they're just inept. I don't believe that. And so if the true death rate is, you know, 10 to 13%, you open this country up and send us out into the workforce, and we don't have testing in place, we don't have protocol in place, you know, there's a 10 to 13% chance that you can go. And we also now know that it does not discriminate against young people. Young people can go too. So it's a real killer. It's very serious. It's not been reported properly, and it's a global issue, right? Like planet Earth is in trouble right now about this. Okay, that's what I wanted to show you here. All right, so now deaths, right? So as reported, the deaths have jumped, right? So if you look, what is this chart saying, right? So the current, this is deaths in the U.S. forecast for 14 days. So 14 days out, we expect 34,000 deaths. We're already at 32,000 deaths. Okay. The equation we have for deaths is 7.905 times x squared minus 479.5 times x plus 4,489. That is a best fit regression curve, and using polynomial fits, and you can see that this is the forecast curve we have, okay, and here are the actual data points, these red points, and you can see that it is increasing faster than our predictions, but this is the curve that best fits without risking overfitting, right? So we have an optimization step where we look at how much error is reduced given the order of polynomial we choose, and the derivative is 0 the second derivative is 0 at polynomial order of 2, and so that gives us the best balance of minimizing error and minimizing the chance for overfitting, because we could you know, fit this line perfectly, Polynomials can do all kinds of things. That's the other reason why we chose a polynomial, because if you chose exponential, this thing would just run. Okay, so we chose a polynomial because polynomials can curve and eventually slow down. Now, if all that being said, and then here's the first derivative, the second derivative, and these are telling you both positive, right? So their evaluations are here. So we add 864 deaths per day. It's terrible, and we are accelerating at 15 deaths per day. So tomorrow it'll be 864 plus 15, which puts you at 879 deaths, and that's our curve. And you can notice that the actual data is moving much faster, right? And another point I want to show you is this, we're saying it's growing quadratically, right? But if you look back, right, let's see, we're at 32,000 now. Let's go back 7 days. So 1, 2, 3, 4, 5, 6, 7. 7 days ago, you were right at around, I mean, it's a little bit less than halfway, but let's just say halfway. You were right at around 17,500, right? And this is more like 16, but let's just say 17,500, which would have been here, but let's just say that, okay? And now you're at 32,000, which is almost double. So in 1 week, you've doubled, right? 1, 2, 3, 4, 5, 6, 7, which is right around 17,000, and you've gone to 32,000. So you've doubled in a week. Okay, that's unbelievable growth. And what is it? For us, we're saying it's quadratic, but the recent increase is showing it to be much faster. Also, there's talks of slowdowns, but how can it be when, look at the distance between these last 2 data points. And that's what the article title is about. It's jumped, this was at, the prior day was 2,494 deaths per day. And we'll talk about deaths per day, but what that means is this is total deaths, okay? This series represents the total amount of people that have died, 32,916. And on this day, 2,494 people died. Okay, so this number plus the 2,984 takes you to this roughly, what is that, 27,000. Okay, so that's all that is, right? Every day we add the more amount of people who have passed away from this, and this chart continues to rise. And deaths will continue to rise and hopefully fall off, but because this is an accumulation chart, it's never going to go to 0. We'll always have this area under here that represents people who have passed away, right? But this jump from here to here, right, from 2,494 to 4,591, 4,591 is an 84% increase. Okay, so that is not a slowdown. This thing is curving this way, right? Slowdowns curve this way, right? This thing is curving this way. And so it's not slowing down, right? Deaths are increasing. Now what about infections, right? So let's look at infections. So here are infections in the United States. All right, so we have 667,801 at the time that the analysis ran. All right, so this is 600 and some odd thousand, close to approaching 700,000. We forecast 900,000 in 2 weeks. All right, both derivatives are positive. You're adding almost 22,000 infections a day. That's just unbelievable. And it's accelerating by 390. So 22,000 today, 21,943 today, and tomorrow that rate will increase by 390, right? And that is what is causing this thing to run. And so we'll talk about the calculus situation in a couple of minutes, but the infections are growing quadratically. And let's again do the same thing. Let's go 7 days back. 1, 2, 3, 4, 5, 6, 7. 7 days ago, this is, let's say, 500,000. It's a little bit less than that, okay, but let's just say 500,000. 7 days ago, you went from 500,000 to 666,000, so 167,000 on 500,000, and that's like what? 200,000 would be, what is that? 10% is 50,000, and so 160,000, so it's like 30%, right? And so it's a big jump. Okay, big jump, and we are on the move. Now, you may look and see this curvature and say that, well, it was accelerating very fast over here. Okay, and so let's just say the slope is very, very high over here. Velocity, very, very high. And now the velocity is not as high, right? And that is true. Okay, the velocity of this has slowed down, but that does not mean it's going to turn over, and I'll talk about that in a minute. Just because it's turning over, or sorry, just because we're decelerating, if you will, does not mean that it's just going to magically turn over. It can just decelerate. The analogy is like you're driving, and rather than you're driving and you've got the pedal smashed to the floor, and you look down and you're doing 100 miles an hour, and you're like, oh my god, I'm going too fast. So you take your foot off the gas, and now you're doing, let's say, 90 miles an hour. But instead of increasing, let's say, 10 miles an hour every second, you're at 90. You look again, now you're at 91. You're at 92. So you take your foot off the gas a little more, and maybe you're at 65, and you're cruising at 65. And maybe we continue to cruise at 65. Maybe we cruise at a constant velocity, right? And that would mean that the second derivative is constant. We're not accelerating, okay? And if that was the case, we'd be accelerating. We'd be at a velocity that's linear, and that is where South Korea is. And I'll show you South Korea in a second. So, but anyhow, there's the United States. Its forecast is high, 900,000, and there's no sign of this curve turning over. There's no sign of this thing peaking. And so, okay, let's talk about the slowdown, right? So there are reports that things are slowing down. Some states are doing good. Some states are doing better than others. We should open up in these states. And our research is just exactly the opposite of that, right? So we've analyzed every country in the world. We've analyzed every state in the United States, including territories and ships. And the only place in the world that has any kind of slowdown is China. And that's an alleged slowdown. You can go to get data and look at the, why we think it's not a slowdown, because we can't trust their reporting. Nobody knows what is going on with China's reporting. CIA has come out and said publicly that there are issues with their reporting. It's in the news that the United States government is investigating China's reporting. We just don't know what is happening there. So no U.S. state is decreasing in deaths or infections. Right? We can prove it. We've analyzed it. Show it to you. And even the least infected state, which is Wyoming, right? I'm very happy for Wyoming, is reporting infection and death growth. So let's look at Wyoming, right? Because this, there's reports that some states are doing great, okay? And so what does that mean? All right, so let's look at Wyoming. So Wyoming, here's a chart of infections in Wyoming. And so these red points are the infections. X-axis, again, is days. So this is the 50th day of this pandemic, right? That's the first day that Wyoming got an infection. They didn't have it on day 0. That was only China and some other countries in Asia. And so on day 50 of the pandemic, Wyoming got an infection. It may have had it before, but that's the first tested infection. Y-axis up here is total infections, right, for the state, and this is time, right? So we're now on, I think, day 88, right? And Wyoming, this is today, right? So Wyoming is currently at 296 infections, right? Now let's go back, right? 1, 2, 3, 4, 5, 6, 7. 7 days ago, Wyoming was at around 1, 2, 3, 4, 5, 6, 7. What is that, like 230? Let's say 250, right? So 50 in a week. But if you go 2 weeks back, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. This is exactly 150, and I've checked it in data, so it is in fact 150. So 2 weeks ago, Wyoming was at 150 infections, and it is now at 296. So it's almost doubled in 2 weeks. And Wyoming is only growing linearly, but it is growing pretty sharply linearly, right? And we think it's going to jump to 426 infections in 14 days. Okay, so they're on the move, and it is not slowing down. This thing is increasing. It has doubled over the last 2 weeks. And again, I'll show you what a chart of what something is slowing down looks like. Right? I'll show you definitively what a slowing down chart looks like, and it is not this. Right? You'll see that when you see South Korea, and you'll see that when you see China. Okay. So, all right. So there's Wyoming, and it's on the move. Okay. Now, if you look at deaths in Wyoming, right? There were no deaths in Wyoming until recently, and now Wyoming has 2 deaths. So this is representing 1 death, and now 2 deaths, and deaths are on the move now. It's early. Okay, and if you look at other charts, you'll see it'll spike and then kind of come down. Well, not deaths will come down, the death rates will come down, but the trajectory of this thing is cubic, and that is because it jumped from 1 to 2 very quickly, right? So if it went from 1, if it was 1 for a whole bunch of weeks and then it jumped to 2, it would not be as sharp an increase here, which is why the forecasts predict that it's in fact cubic, and that's really bad. And so, right now you're at 2. In 14 days, you'll be at 9. What does that mean long term? If you extrapolate out, you'll be at, in 180 days, so 6 months from today, Wyoming will have 1,800 deaths at its current pace. You open it up, it'll be even worse. And you're talking about, in 1 year's time from here, 12,807. Right? Now, if we get a miracle cure, if we get a vaccine, if we get mass testing in place, if things change, then these numbers will change. But at current behavior, without testing all over the place, without protocol to snuff the infections out as soon as they're spotted, without a vaccine in place, without a cure in place, this is what is predicted to go forward. And if you notice from our analysis, each of these points are like beating what we're predicting, right? They're moving faster than us, right? We thought it would be 2 over here, right? So a couple of days later, but it's 2 now for Wyoming. So, okay, so this is not slowing down, right? Wyoming has deaths. Wyoming is forecasting to have more deaths. Okay, and we're talking about 12,000 in a year, 1,800 in 6 months. So there's no slowdown, okay, and I can assure you that. Now let me show you what a slowdown looks like. Okay. So if we go to, let's say, let's look at China. Okay, so here's China's chart. Now again, China's numbers are dubious, right? We don't know what is going on, and something you should notice, I'm going to draw on this, hopefully you can see that. When you make this smaller so you can, it won't be too blurry. All right, so again, over here we have days. China had infections on day 0. Y-axis is the amount of infected. And so, over here, right around day 20, they came around, I was at like 45,000. And then you have this huge jump. Right here, let me back this up a bit. So you have this huge jump from here to here in a day, right? So, really? Okay, so when you look at, charts, and you're looking for things, indications of missing data, and there's various types of missing data, but you look for charts where things are not continuous, right? So at least we can see that it's not continuous. So again, there's questions in reporting about this, but here, this chart, so the dashed blue line is the projection. And if you notice, the derivatives of the velocity and acceleration, first derivative being velocity, second derivative being acceleration, are of the curve, right? And this is actually right here is where they peaked. Okay, so this is their apparent peak. Okay. That's when things started to turn over. But you can see from our predictions that they should be dropping, right? And this chart, it rose. I'm going to kind of sketch along with it, right? So it rose, and it turned, and it kind of got flat and rose linearly, and only after it did that for some time, right, did the projection say, okay, now we think it's turning over. It has to kind of prove it, right? And so right here, okay, is when we said it's going to start to decelerate and turn over. Now it has not. Okay, they've picked up, they've opened up, they've picked up, there's more debts coming in, and you know this. But so this is an example of somewhere where we think that it is going to actually drop, but because the numbers are so dubious, we don't know. And also, even with, let's assume this is correct. Let's assume that their numbers are straight, and they're not misreporting. It's still increasing, right? It's just increasing at a slower rate, but it's still increasing. And if you have a virus that is, you know, spreading like wildfire, and the death rates are, I don't know, even at 5%, or 4.93 where we are across the U.S., that is really, really deadly. I mean, there's a 4% chance that if you get it, you're gonna go. Yeah, I mean, that's what that says. And you know, you'll hear, well, it depends if you have comorbidity, and if you have comorbidity, the chances are even higher, right? But it has killed young people. It has killed healthy people. The flu kills young people. The flu kills healthy people, right? It's just a smaller proportion of the population, but it happens, right? And so the reason why the governors are keeping us inside is because they know there's no protocol to snuff the infection out if it happens, if there's a breakout. They know that there's not testing in place to figure out precisely who has it and who's just got it, right? And they know the death rates are high. They know that it spreads very quickly and that there could be mass deaths. So, okay, but anyway, I wanted to show you this, right? So China, even with this reporting, this thing is still moving, right? It's still on the rise. Okay, so that's fine. Let's save it. Okay, now let's look at South Korea. Okay, so South Korea, which I think is the best case, okay, for where we can go. So here's South Korea, again, x-axis time, days since the infection. They picked up at around day 25, or this looks like day 30, but either way, infections in the, time in the x-axis, infections in the y-axis, and you can see, right here, so, and here's the thing, our trend line for them is linear, okay, and that is much better than being quadratic or cubic. There's some places that are quartic, all right, but they're increasing, but they're increasing linearly, all right, and it may be that over time, right, they have to prove it because they had a whole lot of days where it was low, and you see this is kind of like a sigmoid for the math folks in the, let me change this so it's a little bit thinner. For the math folks in the audience, you'll know what a sigmoid is, and it's sort of a x squared type function where we don't really pay attention until you've crossed a certain threshold and you've made, you know, then you're making all this impact, and after a certain time you're like, okay, you've made your point, there's diminishing returns. And so it's close to that, right? And this is, you know, intuitively giving you an idea that it's leveling off. But is it, right? Well, we know that its growth is linear, right? And with all the testing they've done, and with how quickly they attacked it, right? They are still increasing. Okay. Now, this talk of flattening the curve, if you think about the U.S. curve, the U.S. curve is like, here, right? South Korea's curve is like this. And what this means is in our curves, we're way up here. They have growth. Their growth is linear. And, rather than them having millions of deaths, like are forecast in the U.S., they're going to have, a couple of thousand, right? So we're thinking in 14 days, this is infections, right? So I'll talk about deaths for South Korea in a second, but I wanted you to see this, right? So their second derivative is 0. They're not accelerating, and they're adding 168 infections a day, but even though they turned over, and you could argue that that turnover point is right here, and let's say we're here. I don't think we're here, right? But let's say that we're here. That does not mean the chart's going to do this. That's what your brain interprets, like, oh, it's going to turn over. No, it's not. Okay? It's not going to turn over. There's no place in the world that it's turned over. Even China, which is predicting that it's going to turn over, has not turned over. Right? We know that because we've screened every single country. I can show that to you, but we'd go way beyond the timing on this video. Even this video has gone long. But I can assure you that it's not just going to turn over, right? At best, you will start to move linearly. And that's what they're doing. And then they've flattened it a little bit more, and now they're moving linearly this way, right? But it's like crime. You will minimize it, but you won't get rid of it, right? There's going to be more crime. It's like the cold. We've been trying to get rid of colds forever. We can't get rid of it. We try to minimize it. The flu, we have a vaccine. We've been fighting this thing for centuries, right? We can't get rid of it. We minimize it, right? It's the same thing with COVID, but there's no vaccine. And it spreads like wildfire. And it kills at, what I think is 10 to 13%, right? So it's very, very dangerous. So anyhow, even with apparent slowdown, right, this is what you're talking about. You are not talking about this. There's no evidence for this anywhere. The IMHE model is saying that there will be, this dip, and we'll talk about deaths per day, and they talk about deaths per day, and that there won't be as many deaths per day or infections per day, and that may be, but that corresponds to, instead of the infections being very sharp and increasing here, right, they level off, but they increase nonetheless, right? This is the key, right? Like, is it going up or is it not? If you saw infections per day, you would see a chart which would represent something like, it would look like, okay, infection, 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 and then it'd start to taper off. So then you'd see it's less, okay, it's less, right? And this is effectively the slope changing, all right? So, oh, there's less infections today, and maybe it's holding, and maybe you see over here it drops even more. So that leads you to think that, your brain, this is just how we are, your brain connects the dots and says, oh, infections per day are dropping, right? So infections are going to go away. No, it's not. No, it's not. It'll be minimized, okay? And just as this thing approaches down here to 0, all that's telling you is that it's not accelerating as fast. It's not accelerating at all right now, but the velocity is slowing down, okay? But we still have it. China, even if you assume their numbers are correct, they have not slowed down to the point where it's, turning over and they don't have any infections, okay? South Korea, with all its testing, has not done that either, right? So, yeah, okay, all right. So I wanted you to see that, right? So it's not slowing down in that it's going to turn over. The pace of infections is decelerating, but it is increasing nonetheless. You were doing 100 miles an hour with your foot smashed to the floor. Now you're doing 65, right? You are cruising, South Korea, cruising at 65, all right? U.S. foot smashed to, smashing the gas, accelerating 100, 105, we're going for the speed limit. Right? We're going for the record. We've already passed the speed limits. Okay, so I wanted you to see that. Okay. The other thing to note, actually, that's quite a lot of data for today, but yeah, I think we can leave it there. I want you to know that. Well, okay, wait. Let's look at this. So remember, I talked about deaths per day. All right. So that's the number that's being thrown out. Okay. So or infections per day. All right. So here, this is the Johns Hopkins site, right? And I use Hopkins data. I'm very thankful for them for making it public. You can get at it by going to this website and then looking at their GitHub repo. And what it's saying is, if you look at the United States, 701 now, they've just updated, it's 701,000 infections. And then if you look at deaths, sorry, if you look at infections per day, right, there's daily cases and there's confirmed. So the charts that you see on getdata.ai are this, right, the cumulative infections. And you can see this thing is on the move, all right? Now, if you switch to daily cases, all right, you'll see there's some fall off here, right? There's some fall off here. And, you know, you would be, oh, we should talk about calculus for a second, right? You would say, oh, did it, you know, but when did it start to slow down? Did it slow down here when there was a drop? Well, no, because it picked right back up. And, oh, it fell off over here, so it's slowing down. Maybe, but it's also picked back up, right? So it's very hard to judge from these charts exactly when a slowdown occurs. And that is why you need calculus, all right? And that is why we're saying that there's no confirmed slowdown, because the only way to actually say that something has slowed down that is a curve is to say that it is now concave down, right? And meaning if there's a peak, right? When you say slow down, and you've heard verbiage saying that there's been a peak. Is this the peak? Well, that would mean that the curve that fits this, right, is concave down, and the second derivative is negative. And I'll show you that. Okay, so very quickly, and that is sort of one of the fundamental points that we make in our analysis, right? So I think I've got some charts to explain that here. All right, so here, and I promised to go quickly. I wanted to just kind of explain this and see, so you know where we're coming from. Okay, yes. Okay, yeah, this is good, right? So here is an example of you know, a curve, and let's say that this curve is the let's say this is deaths per day, right? And or this is infections over time, okay? And so, but it can be, you know, whatever curve you want it to be. But let's just say that it's measuring something, okay? In the beginning, it picks up, right? And then it turns over, and then it comes down. When that happens, right? When this turnover happens, the slope at this point, right, is still positive, but over here the slope goes to be 0, right? It flattens, right? And we say that y prime, first derivative, is equal to 0. And you know, if the first derivative is equal to 0, it could be down here too. This is also a flat point, right? This is also a flat point down here, and this is also a flat point down here, and even here we have a flat point. So how do we know that it's a maxima or a minima? Well, if you evaluate the second derivative, right, at this point, it'll be negative, because what's happened is the second derivative is just a change in the first derivative, right? And if you notice that, okay, you know, we were going really fast here, and we're going less fast over here, and so the velocity from here to here, if you subtract it, since it was really fast over here, say, let's say this was like 5, and now this is 4. Well, 4 minus 5 is a negative number. And so over here, you know, we were doing like, let's say 10, and now we're doing 0. So 0 minus 10 is a negative number, right? And that is why and remember, the derivatives are just slopes, right? Slopes are just change in y over change in x. And as that goes to 0, what is it? It's the instantaneous derivatives. And so that's why y prime prime, second derivative, has to be less than 0 to confirm, because you decelerated, right? And if you accelerated over here, same thing. We went to 0 in velocity, and but we were at, let's say, -2, and then we went to 0. Okay, and so that is a positive change. Okay, or if like the new one is 1 minus the last one, right? So let's say over here you were at 0. And now you're at 1, and so you have this positive increase, right? So the changes are increasing, right? And so what you would see is like negative, let's say this was -4, this is -5, so -5, now you're at -4, okay? So both going downwards, so -5, -4, -4 minus -5 is a positive number. -4 minus -5 is -4 plus 5, which gives you 1, right? And so that's why this ends up being an indication, not an indication, but it is the second derivative being positive, right? And you've bottomed, and now you're on the way back up. Okay, so we are nowhere near this point, right? You are over here somewhere. Okay, this is where we are right now. We are accelerating, and I'll do a whole video on the calculus of the situation and why this is the case, but this is the life cycle, and at a very high level, this is why the second derivative's got to be less than 0 to show that we've peaked, and we are nowhere near that peak, right? We're nowhere near that peak. It would show up in the curves. One country has shown up with it. It is China, right? China has predicted a slowdown, and it has not slowed down, right? So they're still increasing. And even South Korea is the next closest, and even South Korea is still increasing. So, and let's look at that. So if we go back, right, so the US hasn't peaked. Well, we know it hasn't peaked because you can see that intuitively this curve has not turned over, right? And it will turn over just like you saw South Korea, right? Let's go back. So you saw, where is South Korea, right? You saw South Korea turned over. This is where the US is, okay? South Korea started to turn over. Has not completely turned over, and it will not until we see that the second derivative goes negative. Right now it's 0. That's good, okay? But not negative yet, right? So, let's save this. All right, now let's go look at Korea on this same chart. All right, so Korea, 10,000 infections. See, there you are. There's that turnover, right? So look how different Korea is from the US. US, Korea. Okay? Now look at their daily cases. They peaked, all right? They had a peak right in here, all right? And they've had some smaller peaks, but they still have it, right? Now, hopefully they snuff it out, but they still have it, okay? And look at this. This is very, very different from what you see with us. Look at our daily cases, right? Does that look like that's not at all, right? So now they've been at it longer than us, and perhaps we'll get there, but there's no indication of that at all. In fact, we are setting records in infections, in deaths, and in death rate, right? So there's no slowdown. I can't believe these numbers. Be careful. I'll do some more videos talking about the mathematics of the situation. Do your best to socially distance. Do your best to stay away from people. Write to your congressmen. Write to your senators. Push for more testing. Write to the governors. Ask for more tests. So much of this improves when we get tests. I want to go see my mom, but I can't see her because neither one of us know if we have it. How do we know we don't have it? We could be asymptomatic, right? And I go see her and I have it and she gets it. She's older and now we're in trouble, right? So so much gets solved with tests, but tests alone are not enough because, okay, you've tested us all, and let's say like 20 of us or 20% of us have it. Now you need protocol. You need to force these people to stay in. And I can tell you, I'll do another video on social distancing. There are people having barbecues. I think there was just some block parties going on, right? So like it's not being taken seriously until it's too late. And Maryland just did some research on that as well. So um, I'll put that. Well, let me show you what that is. So if you do data.covid.umd.edu, right? This is a website that the University of Maryland has put out, and you can see their write-up on this as well. And basically, the states that have higher social distancing indexes, which are, I think, what is it they're saying? Yeah, so the lighter is social distancing, and the darkers are not. Those states that are lighter have had a lot of infection, and so they're starting to social distance. But these states um, have not had a lot of infection, so they're not social distancing. Now, the problem is their findings are that people only start social distancing after the infections explode. But by that time, it's too late, right? So you have to get ahead of it, and you have to be smart about it, and do things that South Korea did, and they got on top of it very quickly, and so and because of that, they're going to have much less deaths than us, right? So yeah, this is at data.covid.umd.edu. I appreciate everybody's patience. I'm sorry for being verbose about it. I hope that you can get some intuition as to why we feel very differently about the situation than everybody else. I think it's very, very serious. I see no sign of a slowdown. I'll do some more videos on this. I'll try to keep some light, and I'll try to give you more of the mathematics of the situation. And all that being said, just be safe, everybody. I wish you all the best. Thanks. Bye.